Good morning. Today in Calculus 30, we're going to continue talking about domain and range of functions. We've looked at polynomial functions and rational functions so far. Today we're going to move on to root functions. And again, I'm going to divide root functions into even and odd roots because how we deal with square roots versus a cube root, for example, are different. One thing that we know about taking the square root, which is an even root, it's all about 2, is that you cannot take the square root of a negative number. And so when we talk about taking the square root of a value, we know that that's going to affect our x values here, and this value here inside of the root sign cannot be negative, and that's going to affect our domain. So in terms of the domain, what we need to keep in mind is that we cannot, and I'm going to say square root, but that's going to apply to all even roots, like a sixth root. You cannot square root a negative number. And as such, that means that the expression inside of our even root has to be greater than or equal to 0. So in this particular case, we have ourselves a domain. What is the limitation on our x values by looking at what is in the inside of our root sign. So for this particular example, we would just simply have to say that our domain can be all real numbers, but keeping in mind that it has to be greater than or equal to 4. Now with a more complicated radicand, that expression underneath of a radical sign, we still have to think about that expression has to be greater than or equal to 0. And we've looked at expressions like this with inequalities earlier on in calculus, where we would look at the sign analysis to find out for what values of x, when we look at its factors, x minus 5 and x plus 5, are going to be greater than or equal to 0. So if you recall sign analysis, going through and finding out when each factor is positive or negative. For example, the bottom factor would be 0 at 5, negative to the left and positive to the right. The top factor would be 0 at negative 5, negative to the left and positive to the right. Because we are multiplying these factors together, 2 negatives will become positive, 0 at negative 5, negative in between, 0 at 5, and then positive for values greater than 5. And that alone is going to tell us exactly where we can have values of x that are going to be greater than or equal to 0. So for our domain, for this particular question, we want values that are going to be less than or equal to negative 5, but also greater than or equal to positive 5. Those would be the values for our domain. Now I'm writing it in set notation, and that's fine. If you would prefer to write it in interval notation, that works just fine. So what kind of answers are we going to get? Because domain is about what values we can put in, but our range is about what values are going to be a result. Are we going to have a limited value for our y? Well, when you take the square root or the sixth root, we're focusing on the positive answers. So y is always going to be a positive answer. So our y's are always going to be greater than or equal to 0. And so that's what we're going to see when it comes to our range. So for even roots, we do have a limited domain. We do have a limited range with those even roots. But what about odd roots? Are there any limitations when we are talking about taking the cube root or a seventh root? Well, no, we can take the cube root, any odd root, of a positive or a negative number. So in terms of the x values that we can put in place of x, we have no limitations. Any values are possible. And again, it doesn't matter whether it is a third root, seventh root, we are still talking about all values are possible for our odd roots. So what does that mean for our range? For our range, if we can take the cube root of a negative number, we're going to end up with a negative answer. If it was a positive value of x, we're going to have a positive answer. So again, we have no limitations on our y values, and our range is going to be all real numbers. That makes the odd roots a little bit easier than our even roots. So moving into some of those transcendental functions, let's start with some exponential functions. When we talk about an exponential function, this is a typical basic exponential equation. We have y is equal to 2 to the power of x as an example. When we look at our variable x, it is the exponent. There is no limitation on what type of values that we can use as a power. So our domain is going to be all real numbers. Can be positive, can be negative numbers. And again, even if you have an expression with more transformation type of values, this is an a value, we still are going to be able to put in any positive, negative, zero value in place of x. So what type of values are we going to get as a y value? Our answer to these exponential questions. If you are taking a power on a 2, a positive 2, that means that we have repeated multiplication by 2. If we're multiplying a bunch of 2's together, positive 2's, we're only going to get positive answers. So we're not going to end up with a 0, and we're only going to have positive answers thereafter. So our range typically for a basic exponential function looks something like this. 0 is not possible, and we're always focusing on the positives. The only time that you're going to have to worry about that being different, the range being different, would be if you do have transformations that are being applied to your exponential function. This negative 2 is going to change all of these positive answers from the power on 1/3, a positive 1/3. And as a result, all of your y values are going to be negative. So when we talk about the range for this particular question, we're going to be focusing on all the negatives, but again, we're not going to be equaling 0. So an exponential equation, the first example here is a basic type of exponential function. The second example has transformations that are going to adjust what would be a typical domain and range. So that's what we're going to have to think about for exponential functions. Logarithmic functions. Now keep in mind that logarithmic functions, logs, are the inverse of exponents. So when you see a logarithmic equation such as this is a very basic logarithmic equation. It has base 10. You don't see that base in this example as you do over here. This is base 2. We assume that this common log is base 10. So when we're dealing with a logarithmic equation, what kind of values can we have for x and what can we have for y? Well, in this particular example, I'm just going to remind you what an graph of a basic log function looks like. When we talk about log of x in base 10, this is essentially what the graph looks like. We have a graph that is approaching the y-axis, but it never ever touches the y-axis. The y-axis acts as an asymptote. Now, why would that be? Well, the y value, first of all, is the answer to a logarithmic equation, and that's typically when we're finding a missing exponent, if you think of this as an exponential equation. So the exponent can be any value, positive or negative. But our x values, what we are taking the logarithm of, has to be a positive value. And by the basic graph, you can see that in our domain, we are looking at values from 0, not including 0, and greater, positive values. But our range in a typical logarithmic equation can be all real numbers from positive to negative. Now, what happens when we have a logarithmic equation that has a more complicated expression here? When you take a look at the basic idea, the x value has to be positive, greater than 0, not equal to 0, but greater than 0. And that's going to hold true for this particular question. When we talk about the domain, what we have to keep in mind is that this expression has to be greater than 0. I'm not going to do the sign analysis for this one, but I will fill it in on my notes when I post them. But we would have to do sign analysis, factor this, find out when x is going to be greater than 0 to find our domain. Our range, on the other hand, again, for logarithmic functions, our range is going to be positive to negative values. It's going to include all y values. Log functions is another type of transcendental function, and the last type are going to be sine and cosine functions. Now, if you remember these sinusoidal functions, and again, I'm going to just kind of remind you of what the graph looks like basically. When we talk about a sinusoidal function with no transformations, we had a curve that went as high as 1 and a curve that dropped as low as -1. The graph could continue forward and backward. So simply, when we talk about the domain, there was no limitation on what values we could take the sine of or cosine. They could be positive angles, they could be negative angles. Now keep in mind, these x values, it would have to be clear whether you are talking about degrees or radians when you are focusing on a sinusoidal or a trig function. But our range for the sine and cosine functions, typically, again, it didn't go higher than 1, didn't go lower than -1, but it did reach those values, those extremes. So we would include -1 and +1. And this would hold true for cosine functions as well. These would be the same. Now, the only time that this range may change, and I'll just make note that the range could be affected by a change in amplitude. If we had a vertical stretch, either direction, we might have an altered range. So amplitude is going to affect our range. It may be larger than 1, smaller than -1, but also a midline. If we were to have a value of k added on at the end of these functions that would rise our graph up or down, we would have a change of our range. So we need to be thinking of those transformations when we are deciding on our range values for these trig functions. So amplitude midline can affect our range. Now, sine and cosine are not the only trig functions. We did spend a little bit of time talking about a tangent function. Now, a tangent function becomes a little bit more complicated. You want to remember that tangent functions are equivalent to sine over cosine. When we think of it this way, as a rational expression, we now have a denominator that we would have to think about when it is equal to 0, because that would affect our domain. And the graph of a tangent function is quite a bit different, and so therefore that would affect our domain and our range. That's basically what we have to think about when we talk about domain and range of these different kinds of functions. Ultimately, again, our goal is to find these values for domain and range algebraically without relying on technology to help us out by looking at a graph. But sometimes we need to visualize the graph to help us with some ideas as to how the graph may be limited or not limited. That's all for today for domain and range. Have a good day.